Now, hello everyone. Today, we'd like to talk to you something more about the atomic world. So this is what we scientists, or for chemists, would pay more attention to. It is our submicroscopic viewpoint. But it is mean by submicroscopic viewpoint. Microscopic means the one which can be seen in at microscope. It is up to 10 to the power minus meter. But for you talk about submicroscopic viewpoint, it is something more even smaller, even smaller than 10 to the power minus 6 meter. So as at this way, up to nano, okay, or maybe picometer. So very small, very small size of those, and this is our building block of those substances. We call it atoms. So before we have got quite different types of atoms in the world. Okay, before we talk about how those atoms they will chemically combine each other, if you there's time to talk about those atoms one by one. So for each type of atom, it belongs to one type of element. So altogether, because of the different combinations of the product, so we would come to the concern to the building blocks. So what is mean by elements? Elements in Chinese we call it 元素. 元素, a very basic a building block of elements in which we have got only one type of atoms found inside. So we call that elements 元素. So you know that water is a compound. Okay, we have a formula H2O. So you may know that this is a chemical combination of two elements, hydrogen and oxygen. Okay, so as per the late up to now is 2010, right? 2020. So 2020, as per year 2020, how many elements do you find in the world? Okay, so how many of them they are naturally occurring? We found that 194 elements they are naturally occurring, and in 2011, we have got about 118 elements has been discovered. Okay, so how about today at 2020? So now I would like to show you this video to tell you those different names of the of those elements. Okay, let's check it.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinize at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells with electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, indolium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsadium, mercenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson. And then we're done. Thank you guys so much for watching. If you like the song, make sure you check it out on iTunes and Bandcamp with the link below.
If you think you'd enjoy other videos like this, make sure you subscribe.
Okay, so you may find that we have got
Kira and
so
Zach
far
are
today
collaborating
we have still
and using
got
Grammarly
about
along the way.
118 elements which have been discovered. And why we have a very slight increase in the past 9 years is because for the difficulty of making a large particle. Okay, so in case for those elements such like 10 something or maybe 11 something, or with the last few named elements, all those they are just man-made. So the is not naturally occurring. So that's why it's just a coincidence that we can find that one by one. And because of the particles inside is too big, so they would be easily decomposed. Okay, or we will call it decay. To form some other substances. So that's why we still have we just discovered about 118 elements as per 2020. So because of that, we have got quite a number of the different combinations of those elements, and here comes billions or even billions of different substances in the world. So all those, they are just a combination of those elements. Now, and for scientists, we love to talk to each other using shorthand method. So that's why they would think of something what we call as the symbols. So the symbols is a very easy way to tell which is which. So to name a few, maybe some of you may know. For water, as said before, is H2O. So you may know that we have got hydrogen, it is H. And oxygen, it is for capital letter O. So very often, if you talk about those elements, they must show it the first letter being capital letter. Okay, for example, for carbon, it is capital letter C. So in case, but you may find that those there's not just carbon, we have C, but also chromium, etc., or calcium. So also they will have a letter C. So how would you make one with another with no which element you're going to talk about without any ambiguity? We need to use a second letter. While the second letter, they are in small letter. For example, calcium. Calcium, this is capital letter C, small letter A. If you talk about cobalt, 钴, so a type of metal is found in transition metals. It is capital letter C and small letter O. Please do not write down capital letter C and capital letter O together, which means this is it is a new compound. We call it carbon monoxide, 一氧化碳. So it is not capital letter C and O together. It should be capital letter C and small letter O, which tells you are going to talk about one element only. While for this one, C and O in capital letter, for science, they will treat it as what? They will treat it as a two elements. Okay, they will treat the two elements, carbon and oxygen. Okay, is that clear? So so the general rule, even though you have got the first letter and second letter cannot tell the difference, so you are going to add the third letter. Okay, for example, chlorine. Chlorine, we will not tell it as CH, instead we call it Cl. Cl. How about chromium? Chromium is a metal. Okay, so you're going to nickel wire, right? One of the metal found in the nickel wire. So it is chromium, CH and an R here. So we have got Cr. So however, some symbols, they are quite hard to remember because they are just taken from the Latin name. For example, potassium, it comes from the word kalium. So the symbol for it is K, it's not P. P means some other things. P means phosphorus here. P means phosphorus. While for sodium, the symbol is not S or SO. We talk of it as Na. capital letter A, capital letter N, and small letter A, which means from the Latin word natrium. So what do I want to tell you here is about those elements names that you need to know. And you, as a Form 3 students, you need to memorize the number, the rank order of this from number 1 to number 20. Okay, I repeat, from number 1 to number 20. So what is that? So it is the first 20 elements found ranked in periodic table according to the atomic number. We call it atomic number 原子序. So you will know it later what is meant by 原子序 atomic number in the next video. So shall we take some time on it and writing down those symbols? First of all, is hydrogen is H, helium. We've got H, we call it He. Okay, so lithium is Li. Now remember the first letter is a capital letter, while the second letter is a small letter. Beryllium Be, boron is just B, carbon just C, nitrogen, oxygen, fluorine. So remember the spelling. Many of you would could not spell it correctly. Neon, the one in advertising sign. Sodium, we found it in in the common source, right? So sodium chloride is here. So the chemical name is in Latin. Okay, it is natrium. How about magnesium? Mg, capital M, small letter G, aluminium Al, silicon Si. So remember, phosphorus is P, sulfur is S. So these two, many of you would get easy confusion. Chlorine Cl, argon Ar, potassium, it is another chemical which use the Latin name. It is K. Okay, calcium, this is Ca. Titanium Tr, chromium Cr, is not Ch. Manganese, right? Very similar to the word magnesium. Can you see that? 12 and 15, very similar. So manganese, so we call that capital M, smaller than N. And iron, another one which comes from a strange name, we call that Fe, because the chemical name for this it is from ferrum, Ferrum, in Latin, means iron. How about nickel? Nickel, it is a coordination metal. The materials making points. So nickel, Ni, copper. It comes from the word cuprum. So cuprum, it is a Latin word which means the ore, the metal ore that found in the island Cyprus, Cyprolosi, and indeed in the past, Cyprus is a place where we have got copper ore. Okay, cuprum. So it is the Latin name. How about zinc? Zinc, it is EZN. Zinc is EZN. Bromine, Br. While you may find those others, they are very strange because all those they are just discovered very early. So at that time, we would especially those people in the European countries usually talk to each other by using Latin, or some of them come from Greek. Okay, Hy Lạp文, and Latin is Latin one. So you may find those things are very strange symbol. First of all, silver. Silver, it comes from the word argentum. Argentum means the metal ore found in Argentina. Okay, ngầm. So argentum. What else is tin? Okay, Sn, it's come from the word stannum. Okay, iodine. I is simply a I. Here, I, nothing different. It is I. Tungsten is very special. It is W. It's W. So you may find that in incandescent light bulb. So okay, a very old type of light bulb. We call that we call that tungsten, W. The one we find it in the filaments in the light bulb. Okay, the light bulb. And how about platinum? Is PT. And what's next is about gold. It is Au from the word aurum. Mercury. Okay, Hg, hydroxyurea, and that is Pb. So you may find that pumbum, we call it pumbum. So you may get those names as this. And what are the in common is that, why do I tell you those are the large atomic number, right? The elements of those large atomic number is because those metals, those elements, they are more commonly seen. So you may find gold. Can you see that? 79. Silver is 47. Copper, you may find it as 29. And then iron, so you may find that iron, where is it? It's 26. And also, and finally, it is tin. 金銀同鐵製做埋咧 number 50 stand up. So what are they in common is that they all those 5 elements that they are with the Latin name. So why? It's because of the year of discovery of those elements is quite early. Okay, while most of the others they will stick back to the general rule by using English name and find out the first letter as the capital letter and as the symbol. Okay, or you use the second or even the third letter and put it in part of the symbols. Okay, so you may get this. Now, how to classify the elements? So they are we are going to classify the elements into quite the different ways. So is first of all is by appearance. Okay, first of all is by appearance. So you may be seeing those harmonies in the metals or non-metals, or even those we call it as a semi-metal. So let's just check one by one. So what is the color of those metals? Well, while you see it, you say that, Mr. Chin, most of them is a silvery. Yes, that's right. Silvery, 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 boring, silvery solid, silvery solid, silvery solid. Silvery solid, this part is not silvery, silvery solid, and silvery solid. A very boring stuff, silvery solid. Just continue, okay? Chromium is a silvery solid. Okay, and for that, iron, it is gray, solid, while it is nickel, it is silvery, solid, and silvery solid, and silvery solid. What is so special is about the copper, right? The copper it is not silvery. Okay, the copper is not silvery, it is brown, BROWN, solid. Of course, you may think of one more metals which is not silvery. What is that? It is gold. Gold. The color of that is golden. Okay, golden solid. So you may find that not all metals they are just silvery, but most of them they are silvery. Okay, most of them they are silvery. How about mercury? I would like to highlight with you here. Mercury is silvery, but this is not solid. It is a liquid. Okay, it is a silvery liquid for mercury. Okay, is that clear? So you may find that too. And how about so you may find those metals. Okay, so what is special about metals here is that all about the physical states, the metals they are all what except mercury is a what. So if you talk about physical state, all metals they are boring solid. They are just solid. Except mercury, it is the liquid. It is liquid at room temperature and pressure. So what is meant by room temperature? For scientists, we usually communicate it as 25 degrees Celsius. So for pressure, it will mention it as 1 atmospheric pressure. Okay, so here comes non-metal. Non-metal. For chlorine, the color of this is greenish yellow. So the one that you may find it in the previous chapter in ocean. So you may find that a greenish yellow gas. Okay, for the argon, colorless gas. Nitrogen, it is a colorless gas. So oxygen, you may find that it is also colorless gas. Hydrogen, it is colorless gas. So what I'm going to tell is some things change. It is some other examples. For example, such like bromine. bromine, it is orange or dark red. We will use dark red to represent the dark red liquid for bromine, while for iodine it is just a black solid. So you may find that chlorine colored, bromine colored, iodine is also colored. And what is more interesting is that chlorine is gas, bromine is a liquid, while iodine is solid, right? Can you see that? So why do I say that three? It's because they belong to the same group. We call it halogens also. So you may find that all those they are colored. How about carbon? Carbon, you know that this is a black solid. Black solid. How about phosphorus? We have got two types. One of them is yellow. The other one is red. We will call that white phosphorus and red phosphorus respectively. We have got two types. Okay, you have got two types of phosphorus. Just like carbon, right? Carbon, we have got at least two types. One of them, it is in graphite. It is black. Sedma. So GRAPHITE, Sedma. Oh, but do you want to talk about diamond, Mr. Chin? Yeah, diamond is not black solid, right? Yes, that's right. It's just a colorless solid, a crystal clear solid. So for how about lastly is about semi metal. Silicon is the case, while the color is a gray solid, and so much for that. So in short, I will please finish the remaining parts about the summary of those different types of elements, metals, non-metals, and also semi-metal. So what are they? About the physical state, metals they are solid except mercury, which is liquid, at room temperature and pressure. Non-metals, there are what? If you talk about physical state, they are mainly solid or gases, right? So that's why you will see that mainly is gases or solid or both, except bromine, which is a liquid. Again, it's a liquid. So in the periodic table, how many elements that are found to be liquid at room temperature and pressure? The answer is two, just two. For metal, one. Non-metal, one. That metal, liquid metal, it is mercury, while the liquid non-metal, it is bromine. Semi-metals, how about that? Semi-metals, the most of them they are solid. That is first part. Second, you talk about appearance. Okay, if you talk about appearance, so you may find that metals they are usually shiny. Shiny, that means they could have can reflect the light, which is with a silvery color. Non-metals, they are usually dull in appearance. It's not so reflective with what colors. So we have got different colors, so we call that various colors. VIROUS, different types of colors are there. Okay, so the table below compares the general properties of different types of elements. If you want to further organize it as metals, non-metals, and semi-metals. Sadly, to say that most of the elements they are metals. Okay, most of them they are metals. Only 17 of them they are non-metals, and only 7 of them they are metalloids, or we call it semi-metal. So we may do a calculations. You may do the calculations very easily. You get to know how many metals, non-metals, and semi-metals are there, right? So you may find that most of them, 118 minus 17, okay, minus 7, 90 something of that they are just metals. How can we distinguish and how can you make a comparison of the three? You may see the table. So the table, I would ask you guys to have memorized it, and especially I will ask that in MCs, so you get to know some of the very special case. First of all, metals they are shiny. When you compare it with the metalloids, they will say that usually silvery. Okay, usually silvery. So could you please mark it? Usually silvery. SILVRY. Okay, I would like to write it the handwriting better. So usually silvery. SILVERY. So usually silvery. So of course you may name something which is not silvery. I said copper. It is reddish brown. BROWN. YO for gold. It's golden. Golden. Okay. How about metalloids? Metalloids, they are gray and shiny crystal or some brown powder, while for non-metals, they are colored mainly for some liquids, and they are gases, but usually in for solid. Second is to talk about the physical state at room temperature and pressure. As said before, it is 25 degrees Celsius, 1 atm. So for metals, they are solid except, can you see the word exception, except mercury, which is a liquid. So you may see the exception being liquid found as bromine in non-metal. Okay, bromine is a non-metal liquid, and most of the remaining, they are just solid and or gases. How about metalloids? They are solid. Okay, and three, because of that, it is reflected by its melting point and boiling point. For metals, they usually high melting point and boiling point, but non-metal is low melting point and boiling point, while for metalloids it's just in between. But it's quite high. If you talk about electrical conductivity and heat conductivity, they will find that they will give a positive relationship, right? We have got, for those with a good electrical conductor, it is usually a good heat conductor. Similarly, if you say that it is a poor conductor for non-metals, you may find that they are poor conductor of both electricity and heat for non-metals. How about semi-metal? Semi-metal is just in between. So it depends on the form. Crystalline form, they will conduct electricity, but you have got that dull powder that does not. Lastly, if you talk about ductility and malleability, okay, ductility is the ability to form to be drawn in wire, while malleability is the ability to hammer into thin sheets. Okay, wire and sheets, thin sheets. So for metals, they will say that it is ductile and malleable, while for non-metal, non-ductile or non-malleable, while for metalloid is neither ductile nor malleable, and sometimes we call that it is brittle. Brittle means once I apply some force into it, for example hammer it, it will not change its shape. Instead, they will crush it into pieces. So we call that 脆, okay, in Chinese. And this is what I would like to talk to you about different elements of the world. Okay, it's time to take a look on the checkpoint, and I do hope after doing a checkpoint you'll get to know more about different elements of the world. So first of all, 1A, now you have listed study of the following list of chem elements: bromine, copper, helium, mercury, neon, oxygen, silicon. From the list, name the metals. Can you name some metals? Yes, that's right. So you may find that we have got in copper. Okay, copper is just one of them. Okay, copper is just one of them. And what else? It is mercury. So MERCURY. So it is the only metal in with the Chinese word without without the part gum. Okay, can you see that? Very often, you may see those metals. We have the Chinese name. So for the Chinese name, they would be something like this. We've got the Chinese character gum as the left hand side, and the right hand side it is unknown, right? So you're going to give this, for example, tong, ngan, tit. So you may find that all those they are with the left hand side being the part of the words. Okay, means metals. How about metalloids? You may find one. It's a silicon. Okay, silicon. So we have got that zinc. Silicon Valley, right? So you know what's that zinc. So the noble gas. Can you think of noble gas? Yes, noble gas is helium. Okay, helium. Hoi. So the one is filled of the replace the hydrogen balloon, right? The floating balloon. This time I use helium because it is rather stable. So the neon is just another case. 氖. So it is found, you may find that what is in common is that if you talk about a gas, right, the Chinese name will usually have this main part, right? While for the part inside that, it can be something else, okay? So this is what the Chinese think of a chemistry. They have their own system. How about the nonmetals? They are not noble gas. So you need to fulfill the both requirement. Nonmetals, not noble gas. So what are they? It's bromine, okay? BROMIN, bromine. So the Chinese name 草. Okay, 草, the water on the part of the Chinese character means something liquid, okay, with a bad smell. Okay, yi, the most abundant elements in the earth crust. Most abundant means the mostly found. So the first one, do you know what's rank number 1? It is oxygen. The second rank, it is silicon. So in your exam, I would also ask you something like this. This is rank number 1. It is the rank 7 most abundant metal elements in the world, in the earth crust. How about the first? How about the first most abundant metal in the earth crust? Do you know? First most abundant. Iron or aluminium? Do you know? Some of them may think that if you talk about price, okay, if you talk about price, it is iron, while the aluminium is a bit more expensive. But if you talk about abundance, it's quite the opposite. So you may find that the abundance of elements in the earth crust. So you may find the table here. So in chemists, we usually use this table. Okay, so what are they? So you may find that you need to memorize those. The rank number 1, oxygen. Rank number 2, silicon. Rank number 3, it is the most abundant metal. It is aluminium, even though it's more expensive. How about number 4? It is iron. Why? Why you say that? Why do I need not judge it from the price, right? Which is more abundant. Okay, aluminium is more abundant, but do you know the way to produce aluminium? It is from what? It is you are going to extract that from electrolysis, okay, a more sophisticated method of their molten ore. So that one, they will cost you price, okay? It will cost you price. So even though it is more abundant, you may find more in earth crust. You may spend more money on doing the extraction. So that's why it is less commonly used. How about iron? For iron, it is made up of what? You are going to heat the iron oxide with carbon. So you may find that from the technology side, you may find that, wow, this one it will cost you less money. It will cost you less money. But if you want to take a look on that too, you may find that iron and aluminium, they are two the most abundant metals in the world. In the earth crust. What I mean is in the earth crust. So remember. So how about Fe, a liquid metal that has room temperature and pressure? So you know what's that? Liquid metal and liquid non-metal. So you may find the two. Yes, that's right. This one is commonly asked. Mercury, Hong or 水銀. Okay, watery sulfur. So those liquid non-metals is bromine. So can you get the point? So this is what we talk about it as question 1. How about question 2? The following table below shows the properties of some unknown elements. Properties in Chinese, 特性 or 特質. So which tells the character while of those elements they would have. So you say that A is a gas, is a Darwin appearance, and then no is not a good electrical conductor. And you may find that to B and C. So classify, you're going to classify those element A to B into metal or non-metal. Explain your answer. So do you know how to answer this type of question? Well, for A, how will you know distinguish metal and non-metal? Is it just from the state? It's quite hard, right? Because it's not unique. But for this part, electrical conductivity, it is the commonly way for you to get to know what is meant by metal and non-metal. Okay, for A and B. So you may find that new and good. So you may get to know that A is a non-metal. While you talk about B is a metal. So you are going to give me the reason why. Okay, so A is a what? A is a gas. So metal cannot be a bad gas at room temperature and pressure. And what's more, it does not conduct electricity. While for B is a metal, so you know that it is from the appearance, it's not just solid, it's also shiny. Okay, B is a shiny. That will reflect light. Okay, and also most importantly, this one is the most crucial part for you to get to know it is a metal. It's because it is a good conductor of electricity. So that is very crucial way to get to know that. Well, B must I would say it for sure that is metal. Okay, so any exception that are maybe some of you may have doubts. Okay, electrical conductivity, can you give some exception like oil to tell you that it is an electrical conductor but it is not but it's a non-metal? Can you think of some exception? So this is something about common sense, right? You need to get to know. What is that? Yes, that's right. It's carbon. In form of what? Graphite. The one that we find it inside the pencil, the black part, mud. We call the pencil lead. Okay. So this part, it is the non-metal electrical conductor. Okay. While for the others, no. So far we cannot find. Which is the electrical conductor, but it's not a metal. So remember, okay, that type of exception that you need to know in your MC. Very often they will ask you something like this. How about B? Which element, B or C, is mercury? Explain your answer. B or C? B or C? C, that's right. Because C, it is liquid. C, I show you, it is liquid. There are not so many liquid in the world, but what's more, so you may find that conduct electricity. So this is the only criteria. So you may find that C is a liquid at room temperature and pressure. And what's more, as said before, it conducts electricity. And it conducts electricity. So this is what I would like to talk to you about this checkpoint. Any questions? No. So if you don't have any questions, shall we take a look on the other part? It is 5.2. It is the structure of an atom. So I will show you in another video.